I'll be talking about screaming interfaces, that is, the interfaces that explicitly tell you what the thing does. Let's start with a bit of my bio. So for the most interesting part of this conference, I've worked for a couple of years at Intel, I think for 7 years. I've been a compiler developer there for GPU compilers for close to 5 years. During this time, I've been one of the authors of OpenCL C++ standard, as well as the reference compiler and standard library implementation. And I've been representing Intel for 1.5 years at ISO C++ Standards Committee. And after that, I've moved to Amazon, who has a really nice banner there. And well, so there goes my my professional work. I don't think I will start with the agenda, but rather with a story, since I think it catches on you better. So first, a couple of questions. Do you think that being lazy at work is good? So who's lazy? Everyone. That's great. I mean, the lazy is what got us out of caves and built us computers and everything. We don't want to do work that we don't have to. And if we have to do work, we want it to be easy. Okay, another question. Who thinks that reading code in a code review tool is more difficult than reading code in your preferred IDE? I do. So those people who didn't raise their hands, they have extra code review tools or really poor IDEs. And well, so I'll start with a story of a code reviewer who kind of looked like me, but was a bit younger, and I don't think he wore glasses at the time. So this younger code reviewer was sitting on a code review, and he was reading a bunch of code, and this suspicious line caught his attention. So he looked at this line with run true false, like this. And it's kind of suspicious. You cannot really tell what it does, right, from the interface or from whatever it's called. So he took a broader look, and we have if new thread and keep data run true false. It seems kind of reasonable. And I know that, for example, I also passed sometimes such things in code reviews, especially if they were exceptionally long. Not everyone has always the time, and some changes are urgent, to pass such things. But we all know that this code doesn't really tell us much about what happened here. So this code reviewer that looked a bit like younger me actually went to the definition of run function. And it was something like that. So it was virtual void run, that we had a Boolean flag spawn new thread and a Boolean reload data. So back to the code, it was not keep data. That makes sense, right? And new thread true. That also makes sense. Okay. So the code reviewer went on and accepted the code review because the rest looked fine. And then when the code deployed, it crashed horribly. And why did it crash? No, it was called. It was just that the main runner inherits from runner base. And in runner base, what we have in run, since you see run is virtual. Anyone sees the problem here? We've swapped the parameters in the inheritance, and our good thread compiler didn't tell a thing. Because why would he? I mean, these are two booleans, right? And you name them as you please. So we didn't tell our compiler. And everyone loves that, right? I mean, so it would be perfect if we could actually tell our compiler, no, these two booleans are really different guys. We don't want to swap them around to mess with them. And also, it would be great if they looked in code review as we wanted them to be. So it would be like spawn a new thread. Yes, do it. And reload data. No, don't do it. So it would be great if we had something like in Python. In Python, you can force people to use named parameters. So if you define your function like that, they actually have to write spawn new thread equals true and reload data equals false. And in this case, it wouldn't pass the code review if it was wrong. but we do not have named parameters in C++. So I think that's it for my presentation, probably. Maybe not. Yeah, it was reversed. So it was like it was reload data here is first, and in the overload, reload data is second. Yeah, I mean in Python you don't really get virtuals and things like that, but the general behavior I want to get is to name our parameters in C++, something like that, basically. So it would look like that in code review. And, well, we can do it. We can do something like that. And that is based on Andrzej Krzemiński work. So what we actually went and did here is we, prior to that reload, created in a single line of code a distinct type, Boolean type named reload data that converts to bool, so we can use it in ifs and everything like we would use normal bool, and separate distinct type spawn new thread. That's also a Boolean flag, but a very different flag than this. They do not convert to each other. So the whole point is now that you first cannot make a virtual overload. I mean, you cannot override the virtual function because the compiler would complain. And if you complained, and if you do it properly, still in the code review, when you don't have go to definition, you cannot hover over the code sometimes, you still see run, reload data true, spawn new thread false. And then our signature looks like that, which is somewhat redundant, but I can live with it. And we define our types like that. So we have our helper named type that we specify the type of what we're naming. It's great for types that do not really convey much meaning, like integers, strings, booleans, vectors of ints. It doesn't tell anything, right? It's a type that can be used anywhere. So now we can name it. We pass a tag name that's only used here. It's just for the compiler to differentiate those two types. And bam. In 2 lines of code, we have 2 distinct types that generally help us live with this code. So I'll show how it's implemented. It's actually quite simple. It can be done like that. So you just have explicit constructor. It's a template type. So it takes bool. It's okay-ish implementation. I don't really use it in my code. So I use a slightly more complex one, but still pretty simple. So what we have here is we have const expression explicit constructor that actually is finesse on whether what we pass is exactly the same type as we want it to be for the flag. So you, for example, cannot write spawn new thread 10 because 10 would convert to bool and it would be true. That's silly because you don't know the intent of the programmer. So if he writes spawn new thread 10, maybe he expected to spawn 10 threads, but you just spawn only 1, so I don't want that. So if it's Boolean flag, then you have to pass Boolean. It has second constructor to allow to convert from different flags of the same type, but it's also explicit. So in case your other module has maybe not spawn new thread, but use new thread with generally the same, that carries the same meaning, we can still convert it from here. We have conversion operator to T, so the type can basically be used like the type that it wraps, and the necessary plumbing for that. So that's the finish of our first story, and then we'll carry on with our review ghost stories. So then this code reviewer that was kind of similar to me, but as I've said, younger and wore no glasses at the time, he saw a different line in the code, like that. Now, whenever we see a pointer passed to function and the code base doesn't use smart pointers and everything, everyone's on their toes. So our code reviewer went into the code and checked. It looks like this. Okay, so it still makes kind of sense that pointer is checked. Okay, or does it make sense? Exactly. So first of all, we have some problem here because the pointer is dereferenced. And prior to the fill function, there was no check for null. So we can either assume that someone somewhere checked for the null, or if we're cautious, we write another if pointer is null, carry on with your work. The same goes for popular class of problems with Sql injection. So for example, we say something like that. And maybe this string was validated, or maybe it wasn't, and it would be something like our parameter semicolon drop database or something like that, which generally we wouldn't want to happen. So these kinds of problems cause us to write, if we're cautious, we write ifs everywhere. We check if it was sanitized, we check if it's non-null, etc. So I've seen code bases which had around 15,000 checks if pointer is not null inside of around 50,000 lines of code base. So basically half of the code base was if pointer is null and what to do afterwards if it is. And this amount of ifs takes a lot of time since our branch predictor can only handle around 30 ifs. If you go through the code, you have a lot of mispredicted ifs, and generally it's a problem. So if we go to this function with database query, we see that the string is not sanitized. So it also should be preceded with some validation of the string, or maybe it was validated somewhere like up the code base when it was collected from the user, or maybe it's our string. We have no clue what happens here. And with code review, you kind of have a lot of code locality. You do not jump around the code all the time during the code review. You basically read what's in the file, and it's best if it makes sense, if it tells you the entire story, what should happen. So looking at such stuff, I came to an idea. Probably a lot of people also figured that out, but well, what would be best here would be if these functions look like that. So we have fill that takes non-null int pointer, and if we have this database query that takes sanitized string constructed from the SQL. So we have classes that right now, if we look at them, we kind of know, okay, this fill takes non-null int, and probably this non-null takes care of it to not be actually non-null. So how can we write that? We can do something like that. If we have a validated type, that's one new helper that I'm introducing here. It's a type that is also a wrapper around some basic type that you pass a validator to. And basically on construction, what it does, it checks the condition here, and later on, you do not have to do it anymore, because if the type was constructed, the condition was checked. So anywhere, in every place in the code, if you see non-null, you're 100% sure that somewhere up the code, someone was smart and checked if it's non-null. The same goes for our sanitized string, although I wouldn't include on a slide SQL sanitizer because it would be probably a bit too long to fit on one slide. But here I have a non-null validator that works, I mean, as expected, and it's quite simple. So what do we gain from here? We gain two things. We gain performance, because we do not have to repeat those 15,000 if pointer is not null checks in our code base. So that's one thing, because we only do it one time per each pointer lifetime. So that's one thing. We also have a lot more clarity because we actually know what comes into our functions. We have a lot more expressiveness too. And well, but some people might argue that, for example, for non-null, it comes from, let's say, new, so it cannot be null. So we'll fix that in a moment. So how I implemented the validated type, it's a pretty simple class template. It also wraps our value. It has the conversion operator, which is nothing really special. It has a constructor that sets value and runs this validation function on it. If it passes, it's okay. If not, it throws an exception. And also it has a second constructor in which we pass validated tag. I think I named it, I validated it, but maybe something else. In general, it's just tag dispatch to say that yes, I'm sure the type is validated. So for example, for non-null, it would be okay if we took a pointer from new and write, okay, it's a non-null pointer right now, and we validated it because new checks it, so we have some guarantee. On the other hand, if it's some different pointer, then we would just use it with a validator. So that's basically for the second story. Now we have the third story of our code reviewer. I mean, he's still pretty lonely and depressed about the code quality that he has to review, but I mean, it's getting better. He introduced 2 cool helpers in his code base and tries to make people use them. Then he sees something like that. Okay, it doesn't fit really well on the slide, but the thing is we have a function that's named latest logs from. We have a count, presumably the count of logs, and the ID of the machine that we want to collect it. It's in an environment where you collect logs from different machines. And this is a function that what it does, you first have a vector of strings, logs, that you gather logs from all machines. Then that looks like a filtering function that takes like latest number of logs probably. And then he filters them out using the ID of the machine. So does anyone see any problems here? Okay, so what are the problems?
Basically, we should filter them along gathering.
Exactly, because right now our function that takes latest logs from a machine might return, for example, an empty vector, even though there were logs from our machine. Because we first take, like, let's say 10 latest and then filter them out of this 10 latest, what happens? So the root cause of the problem lies in a fact that vector of string does not have any meaning at all here. It's not only latest logs from the machine, but logs from all machines, latest, filtered logs, whatever. So everything happens from here, and all these functions can be swapped around. But it makes no sense to swap them around, right? When I gave this presentation for the first time, I have shown one different method how to do it, but it took like a couple lines of code per each set of functions to do it. So it was not really what I would want to do, as we all are C++ programmers and we all are crazy about saving characters and writing, like, if you have to write another line of code, it's horrible, but if you have to write like 5 lines of code, it's extremely horrible. So well, I said to myself, okay, I need like an hour or so to write a helper that would be able to do it in 1 line. And then after like 2 weeks of digging the standards, I think, okay, I'll write to Luis Dion because he works at Amazon too. He's an extremely smart guy, so I'll write to him and see if he can help. So he said, okay, it should be easy. And then 2 weeks later, I didn't have any email back from him because it turned out it's not that easy to write this helper. So then I wrote to my good friend from Intel, and after another like 2 or 3 weeks, he came up with a nice 100 or so lines of code helper that made it all easy to declare. But then it turned out that I'm actually quite good at shortening code, so I'll show you the helper on one slide. But the story behind this helper is, it's not as easy as it looks. But let's get back to our problem. We have something like this in our code. So we have a set of functions that can gather logs. And then after these functions, we have a bunch of functions that do some filtering. And then we have some other functions that do like some final refinement or whatever on those logs. And the workflow is always as follows, like gather, filter, and do some getting on the logs. And if you looked at the documentation, you would probably see it. But I mean, it's not always that easy to get to the documentation. It's not always the fact that you do have documentation. It's not always also that the documentation is from the same time period that the code is. And so basically these things happen. And the best thing would be if we could just look at the code and see this picture in our code. So how to do it? How to enforce the flow of the program just with the types. And we have the flow and what we can do. So we would introduce a couple of types. So we would have top logs. I don't know why it doesn't display, but it should. Then gather logs function would take nothing as it used to, but it would return logs in bulk. That's one type. Then we have filter logs from the machine, and it takes bulk logs. Not some vector of strings, but bulk logs type. And it returns filtered logs. And then we have get functions that take filtered logs and return top logs. So we introduced like 3 new types. And if you want to have a top logs, you can go to the code and just do search whatever returns top logs. So you would see 3 get logs functions. So how do I invoke them? They take filtered logs. So who can produce filtered logs for me? We would see those 3 functions, and so on and so forth. So that's kind of nice, but it requires 3 new types. And if we were to code 3 classes that have friends to these functions or classes or whatever, what produces it, it takes a lot of code. So what I would want to have is to have those helper classes declared in a single line of code. I mean, that's my goal to, and I think that's a reasonable price for code clarity. An extra line of code is great if the code then reads better. So our header would look like this. We introduced a third nice helper. I named it produced type. It wraps a vector of string as the all previous helpers. And then it gets a list of classes that can produce this type. Then we have filtered logs and 3 classes that can produce filtered logs and top logs that can be produced by those 3. I mean, it's pretty similar to the flow diagram that I've showed earlier, right? It's basically, although it's written, but it's kind of written in plain English, bulk logs are produced by gather logs and gather logs from time zone, etc. So it's just the English language mainly description of our design. So that's great self-documenting code. And now to the kind of iffy helper, the produce type, which took me quite a long time to get. And I'll explain in a moment why. It looks like that right now. So we have a T that we wrap, and we have producers that can produce it. So the problems with it were as follows. The producers cannot be functions because we are creating the type that the function here would return. So we first have to have the signature of the function which would return the set type, and we have a circular reference here, so that goes immediately out of the scope. So these have to be classes. And we would want to friend them. But standard, for some reason, I'm not sure why, but forbids parameter pack expansion in a friend declaration. So I couldn't write friend, producers, 3 dots, and be done with it. Also, the problem is that you cannot inherit friendship, which is a very reasonable thing in standard, because if you could, you would expose details of other classes via inheritance, which is horrible. we wouldn't want to have that, but it would be helpful here. So what we are doing here actually is we're using, first of all, we're using Boost Preprocessor, and we're using a nice feature of friendship that you can declare the same friendship multiple times and it's not an error. So you can write friend A, friend A, friend A, friend A, friend A, like hundreds of times, and it's not a problem for the compiler. So it would be just the same as a single declaration of friend A. And we use this macro, Boost Preprocessor Repeat, to expand our macro friend of to the limit of Boost Preprocessor Repeat, because we cannot use count of producers here because it's still at the preprocessor step, so we do not know how many of those will be here. So we actually have to expand it as many times as possible. And now what friend of does. Friend of creates a friend from tuple element t. That's helper type from standard library that takes nth type from a tuple. And what we do here is we create a tuple of producers and index them with whatever the macro here passes us as a count. This macro passes like counts from 0 to the limit as n here. So we take 0th type of our tuple of producers first, second, etc. And if you notice, I'm using min here because we're passing a lot more than we will have types here, so we have to limit ourselves to the count of elements in tuple. Now there's also the tilde here. That's a very useful thing to do when you have macro that takes more parameters than you're using. I'm not using this d parameter here at all. This is a Boost standard to use tilde as a character for that. Some people use something like ignored here, but that's a huge problem because ignored can be another macro that expands here and does horrible stuff to you. And macro cannot be named as tilde, and tilde is also included in the character set of C++, whereas, for example, at or, I don't know, some other characters are not. So we can just place it here and it gets ignored properly. So we have this macro logic here, and, well, and constructor, basically. Private constructor, so only the producers can access it. Any questions here? Because it's kind of complex in comparison to other snippets. Okay, so you're great people. Most people do not get it at the first time, but so I'm like 3/4 of my presentation right now, and I'll show the one more technique and one more problem that happens mostly in code reviews, but not only there. So there's the final arc of our lonely code reviewer story. Our reviewer spots something like that in the code. So what does it do? Who knows? No one knows. Come on. Mateusz knows. I'm sure he knows what it does. It what? No, size is an actual parameter. Like, okay, it doesn't declare a function. It's a call to constructor as a hint. It's a call to constructor, but which one? What does it do? Creates or reserves? Okay, so vote. Creates. Reserves. Okay, so two people. Okay, you're a decent crowd. It creates a vector of this size and fills it with zeros. Yeah, it would be reasonable if it reserved, but it creates vector. So our code reviewer look at the code, and that looks fishy. I mean, if you create a vector and fill it with zeros and then push back something, it looks like you wanted to reserve it. So our code review author actually wanted to do something like that. And now, what if we could name constructors? I mean, I don't know any language that can do that, but I hope that, for example, STL 2.0 introduces like sort of named constructors. And what we can do is we can use tag dispatch to write something like that. And with our vector, it would be far more readable if we pass tag value reserve and set vector reserve 10 or vector default field 10. Everyone would know what happens here, right? And we wouldn't have to take this vote, whatever it does. Especially that, I guess, all people that do know that have made the mistake of doing it wrong. Sorry? Yeah, for example. Well, because for most time you like constructors. I mean, constructors are okay. You can have a factory function that does that, but I do not, because it's a constructor. You do not have to move. Factory function would have to be static, right? And move out are a vector outside, right? Or standalone function like create a vector. Yeah, okay. I mean, it would be equally fast, but do we have any place in C++ where we use factory functions for standard types? Okay, yeah, make unique, make array. True, that's true. But also in a lot more places we use tag types. Yeah, but I mean, it's just a technique. I'm not advocating that it's the best possible way to solve the problem. Okay, I said it's an easiest way. Yeah, I mean, it could be done, definitely. On the other hand, would you want to have a like freestanding function create vector, or would you want to have a static function in vector that creates a vector, and then like 15 or so functions for that, because vector has a lot of. Okay, yeah. I mean, that's a matter of preference. I know I like constructors kind of, but to each his own, I guess. Nonetheless, it can be done like that, and it also reads nicely that vector reserve 10, it reads in plain English, right? If it was a function, it would also look like that. Yeah, so it would be equally good, I guess. That's true. Yeah. Yeah. Okay. What else? Okay. Yeah, that's true. I mean, you. Yeah. So I mean, I kind of like the tags in constructors if we have like ambiguous values to pass to them. And not only in constructors, I guess. I mean, there's a lot of cases in which you pass like something that doesn't convey much meaning, like 10 here. I mean, it's 10 for reserving, and this 10 is for size. It in both cases it means size, but we get different results. So tags are a decent way to do that. So I like it. As it was said, you can also use functions for that. So whatever is your preferred way. And well, and here I'm just showing how it would look in code. So that would look like that, and that's basically it for the code reviewer and his stories. So if there are any questions, feel free to ask them. This? Okay, so what happens here is quite simple. We declare a structure and a const expression value of it. And this is the only value that we'll use. And the constructor takes something of this type, and we actually pass this value, which has a nice name that reads kind of container default field size. And makes sense. Okay, any other questions? I kind of expected a lot more questions with this friend example, but
Yeah, I would try to make it a one parameter constructor actually, yeah. So why should we have like default field tag and reserve tag and then size tn?
oh yeah, you can use named type and write reserve and
Have a type which takes a constructor from integer.
yeah, sure. I mean,
Just
there's a lot of techniques you can use, but you could also use like named type with n, and it would be equally readable, I guess. You would use two braces instead of a comma, so whatever is the preference. So yeah. Any other questions? Okay, so let's start from the beginning. Named types in some form, I think that they are named explicit, are available at the explicit library by Andrzej Krzemiński. The validated types are also there, but somewhat different. I mean, the ones that I have shown, where are they? Those ones. They take validator in construction, and Andrzej's validated types do not do that. So they're just for specifying contract that this function takes a non-null. So it's basically like a named type, but he names it differently. So this implementation is not anywhere, but it's extremely simple. So, and also I think that the slides would be shared. I'm not sure if that's the case. Will the slides be shared after a conference or not? Okay, so then my slides are copyable here. As far as this goes, no, it's not anywhere. I didn't publish it anywhere. But as it seems, the slides would be available. And as the tag dispatch goes, it's a fairly known technique. So.
regarding the name times, as we said, we are lazy, yes? So I think that it could be better just to somehow make the name of the unvalidated entry longer and pay user each time he has to pass the unvalidated stuff to the other function to force him to validate it as early as possible, not to pay for extra characters in every function he using.
Okay, I mean, that makes sense, but
What I'm trying to say is that unsafe things should be penalized here.
yeah, but with named types, you cannot pass like raw bool. You will just have compiler error. So in this case, I think the laziness comes from the fact that you don't have to reason a lot about the code. You just don't have to go and see the implementation of function or just its signature to see what this bool means. If you see true in the code, you have no clue what it means. It might be named well, but then you actually have to trust some other programmer that he named the variable well or not. And in case of name type, you just have the type, so you know what it means. So there's the laziness, but I guess it's hard to make something shorter than a bool or an int. And the best thing I could come up with was to make it not compile if you just pass a naked bool or a naked int, so that you have to add some meaning to it in form of a type. I mean, right now I work at Amazon and not in a C++ team, so I write in Java and I mean pitchforks and everything incoming probably, but my current team does not use it, and I've come with most of this stuff after I stopped writing professionally in C++, so not, but I know for a fact that explicit name types are used in some places, and these things that I have shown have some value in a way that your code is, first of all, easier to reason about, because your compiler guarantees you some stuff. For example, in case of validated type, it guarantees that someone somewhere did a validation and you don't have to care at all about it. In case of named type, it just carries a lot more meaning. So your function name can be, for example, simpler. Your overloads and overrides get simpler, and so on. In case of this produce type, you can move parts of your documentation into your code and it still reads well and nobody has any trouble with it, because compiler will hit him in the head if he tries to do something wrong. And if he tries to fix it, like, for example, where it was, like adding here something, you can just punch him during the code review, right? So if something didn't compile and someone adds something here, you kind of know that you have to pay attention here what he does and if it makes sense or not. Whereas if it's like that, it can be easily mistaken, especially if those functions were not named as well as they are, and those locals were also differently named, so it's harder to spot than something like that. Okay? Okay, so you would want to have a CRTP base with factory, but then you would have to inherit from a lot of those bases, and how you would invoke the correct base for... Yeah, but friendship is not inherited. Friendship is not inherited. Okay, that makes sense, but I'm not sure if it would work. I mean, we can try it after my presentation. That makes sense. Would it be shorter than this? I'm not sure. Would it be more readable? That's possible. Yeah, sure. More readable. That's yeah. That's true. I mean, we can try it after the presentation, because I'm really interested to do it better. That's the best I could come up with. So if it would work, I would update the slides. I mean, I have a template metaprogram library developer here, so let's do it. Why not? Okay, anything else? No, I've used explicit for that, but I mean, I'm just showing some techniques here. I certainly do not think that my implementations are the best around. They're probably not, because these are rather to showcase that you can use something and the implementations are designed to fit on one slide. So if I were to do it like production quality, they would probably be much longer, and they would probably give much better compile time validation and things like that. So I wouldn't really recommend using them as they are, but rather to kind of have an insight into a concept of writing your code so that it reads better, and that the compiler can actually help you reason about a lot of logic that it's not typically used for. So for example, that someone somewhere validated something is not the typical thing that compilers do. But with type system, you can guarantee that. And actually, it can be done quite easily. So that's the thing. The same thing goes for, like, can compiler check if you swap two bools? No, it can't. But can it check that if you swap two named types? Of course it can. So there are some concepts that if you wrap them, if you restate them in a type system way, they actually become very easy and automated by the compiler. And a lot of logic can be actually pushed down on a type system and resolved by type system that we usually check in our code, that we guarantee with tests and everything. But on the other hand, we can guarantee a lot of such things just with types. So that's the whole point of the presentation. Okay, I think I'm past my time. So last question, if there is. Okay, that's great. So thanks, guys.